Hello children, hope all of you have done your homework that I had given to you in the last class. Okay. In today's class, we will move on to the second session. In metals and non-metals, the second session will learn about few new things. Before that, we will see what we learnt in the first session. We learnt about the physical properties of the metals, the physical properties of the non-metals, the reactions of metals with oxygen, reactions of metals with water and reactions of metals with hydrochloric acid. In today's class, we learn about the chemical properties of the metals, the reactivity series, the reactions of metals with non-metals. First of all, let us see how magnesium and manganese react with dilute nitric acid. In the previous class, we learnt about the reaction of metals with hydrochloric acid. Now, let us see how they react with nitric acid. Magnesium and manganese both react with dilute nitric acid and produce nitrates, and in the process, in the reaction, hydrogen gas is liberated. Now, if you can see the reaction, magnesium is reacting with very dilute nitric acid to form magnesium nitrate. In the process, hydrogen gas is evolved. And you have to remember, most metals do not produce hydrogen gas upon reacting with dilute nitric acid, because nitric acid is a strong oxidizing agent. Hence, hydrogen gets oxidized into water. And you can see here, manganese also reacts with nitric acid, which is moderately dilute to form manganese nitrate. In the process, hydrogen gas is evolved. The nitric acid oxidizes the liberated hydrogen into water, and it itself gets reduced to any of the nitrogen oxide. It could be nitrogen monoxide, nitric oxide, nitrous oxide or nitrogen dioxide. When magnesium and manganese react with dilute nitric acid, hydrogen gas is liberated. You saw that reaction. You saw in that reaction that magnesium and manganese react with dilute nitric acid to form their nitrates, and hydrogen gas is liberated. Now, let us see how we can decide the reactivity of metals by their reaction with dilute acids. Whenever a metal reacts with an acid, you know that hydrogen gas is evolved. So, when the hydrogen gas is evolved, you see that the bubbles, it is coming out as bubbles. If the bubbles are released quickly when the metals react with dilute acids, then the metals are highly reactive. When they react with acids, dilute acids, and during the reaction, if the bubbles are formed very quickly, if the bubbles are released very quickly, they are highly reactive metals. Now, you can see here potassium, sodium, calcium, magnesium and aluminum. So, when we conduct experiments, and we can see here when we conduct experiments, we know that aluminum is less reactive than magnesium, magnesium is less reactive than calcium, and calcium is less reactive than sodium, and sodium is less reactive than potassium. That means, potassium is the most reactive of all these metals. So, the bubbles are very quickly released and slightly lesser in sodium, slightly more lesser in calcium, slightly more lesser in magnesium and very less in aluminum. If the bubbles are released moderately when they react with dilute acids, they are moderately reactive. Now, zinc, iron and lead are moderately reactive metals. In that, zinc is most reactive, the next is iron and the next is lead. And if the bubbles are released very slowly, or if the bubbles are not at all released when the metals are dilute acids, they are the least reactive metals. Now, you can see the least reactive metals: copper, mercury, silver and gold. Among these four, copper is more reactive, mercury is less reactive, silver is even more less reactive than mercury, and gold is least reactive. And now let us see how the metals react with the metal solution. Chemically, more reactive metals displace less reactive metals from their metallic solutions or molten compounds. So, when you react a metal with another metal solution or the molten compound, if the metal is more reactive than the metal in the metal solution, it will displace the metal from the metal solution. For example, when an iron nail is placed in copper sulphate solution, iron displaces copper from copper sulphate solution. That means, iron is more reactive than copper. Now, you can see here, this is an experimental setup where you take the iron nail in a copper sulphate solution. In a test tube, the copper sulphate solution is taken, into which you introduce the iron nail. After some time you can observe that the copper sulphate solution has almost turned green in color and the iron nail is coated with the copper. And in another test tube, you take copper wire and iron sulphate solution. So, you keep this for some time, this setup for some time. Now, what you observe is that the blue copper sulphate solution has turned green and the iron nail is coated with a copper metal. But that does not happen in the case of iron sulphate and the copper. The copper, it will not be able to displace the iron from the iron sulphate solution. The reaction is like this: copper sulphate, when it reacts with iron, it forms iron sulphate and copper is displaced. Now, let us see how this displacement reaction exactly takes place. As I told you, chemically more reactive metals displace metals less reactive than them from their metallic solutions or molten compounds. All metals do not have the same reactivity. We have tested the action of oxygen and water and acids on different metals. All of them do not react with the same intensity. Displacement reactions provide us evidence for reactivity in the metals. Metal A, when it is reacted with salt solution of metal B, and suppose metal B is displaced and salt solution of metal A is formed, then that means that metal A is more reactive than metal B. It is taking away metal B from the solution. Metal A is taking the place of metal B in the salt solution. That means metal A is more reactive than metal B. Now, you can see here metal A is reacting with the solution of metal B, the salt solution of metal A, and metal B is displaced. You can see the reaction. So, here metal A is taking the place of metal B, that is why metal A is more reactive than metal B. Now, let us see how metals react with non-metals. Metal ions react with non-metals to form what are called as ionic compounds. Metal ions react with non-metals to form ionic compounds. Now, you can see here, this is salt, common salt or the table salt we use, which is sodium chloride. This is an ionic compound. The metals transfer their valence electrons to the valence shell of non-metals, which results in the formation of ionic compounds. The transfer of electrons is necessary for atoms to obtain the noble gas or the octet configuration. Generally, in any reaction, that is what happens. So, all atoms move towards obtaining a noble gas or the octet configuration, which is the stable configuration. So, in this process, generally they lose or gain electrons. So, they transfer electrons or they accept electrons. Now, let us see what is aqua regia. Aqua regia in Latin means royal water. This is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio 3:1. So, concentrated hydrochloric acid is taken in 3 portions and concentrated nitric acid is taken in 1 portion. So, 3:1 ratio hydrochloric acid and concentrated nitric acid mixture is called as aqua regia. Now, what is the speciality of this mixture? Aqua regia can dissolve gold even though neither of these two acids can do so alone. You cannot react gold with concentrated hydrochloric acid nor with concentrated nitric acid, but when you mix them together and react it with gold, it definitely reacts with it. Aqua regia is a highly corrosive and fuming liquid. It is one of the few reagents that is able to dissolve gold and platinum, which are otherwise non-reactive metals. So, now this is aqua regia. Now, you can see gold is reacting with aqua regia. Now, let us see what is reactivity series. The reactivity series is a list of metals that are arranged in the order of their decreasing activities. So, the activity series or the reactivity series is a list of the metals which are arranged in the order of their decreasing activities. After performing the displacement experiments, the reactivity series has been developed. Now, let us see how the metals react with the acids or the reactivity series.
In this experiment, we will determine which of copper, zinc and iron is most reactive and least reactive. For this, we need 2 iron nails, 2 pieces of zinc strips, 2 pieces of copper strips, iron or ferrous sulfate, zinc sulfate and copper sulfate. Additionally, to conduct the experiment and prepare the aqueous solution of the salts, we will need 6 paper or plastic cups, a spatula or ice cream stick and water. Prepare an aqueous solution of copper sulfate by adding a spatula full of the salt to a cup of water and mix till it dissolves. Pour half of the solution that you have prepared into a fresh cup. Repeat this with zinc sulfate and ferrous sulfate salts to prepare their aqueous solutions. You will now have 2 cups containing copper sulfate, zinc sulfate and ferrous sulfate aqueous solutions each. In the cups containing copper sulfate solution, add the iron nail and the piece of zinc strip. In the cups containing zinc sulfate solution, add the iron nail and the piece of copper strip. And in the cups containing ferrous sulfate, add the piece of zinc strip and copper strip. Let the metal pieces rest in the salt solution for about 30 minutes. After 30 minutes, remove the metal pieces from the salt solutions and observe if they have undergone any changes. Reactivity series is the order of elements arranged from most reactive to least reactive. It is used to determine the product of single displacement reactions. In this experiment, we place the 3 metals in the salt solutions of the other 2 metals. As a more reactive metal can displace a less reactive metal from its salt solution, We can determine the most and least reactive metal basis our observations from this experiment. The pieces of zinc strips in the ferrous sulfate and copper sulfate solutions have a film formed over them, which indicates that zinc has displaced iron and copper from their respective salt solutions. This shows that zinc is more reactive than both iron and copper. The equations for the displacement reactions are zinc plus copper sulfate gives copper plus zinc sulfate. Zinc plus iron or ferrous sulfate gives iron plus zinc sulfate. The iron nail placed in the copper sulfate solution has a brown coating on it, which indicates iron has displaced copper from the copper sulfate solution. However, the nail in the zinc sulfate solution has not undergone any change. This shows that iron is more reactive than copper but less reactive than zinc. The equation for the displacement reaction would be iron plus copper sulfate gives copper plus iron sulfate. The copper strips in the ferrous sulfate and zinc sulfate solutions have no buildup on them. This indicates that copper is less reactive than both iron and zinc. Summarizing our findings, zinc is more reactive than iron and copper. Iron is more reactive than copper but less reactive than zinc. And copper is least reactive of the three metals.
The activity series or the relative reactivities of the metals is like this. You can see a list of metals arranged in the decreasing order of their reactivity, starting from potassium till silver. You can see that the reactivity is decreasing. Potassium is the most reactive, then comes sodium, next will be calcium, then will be magnesium, and next aluminium, zinc, iron, lead, copper, mercury, silver, and last you will find gold and platinum, because they are least reactive or they are non-reactive metals. Now, let us study an activity. Say suppose there are 4 metals A, B, C and D. They were taken and added to the following solutions one by one. The result obtained were tabulated as follows. So, metal A did not react with iron sulfate, but with copper sulfate it showed some displacement reaction. Whereas metal B, it showed displacement reaction with iron sulfate and no reaction with copper sulfate and no reaction with zinc sulfate. And metal C did not react with iron sulfate, copper sulfate or zinc sulfate, but with silver nitrate it showed some displacement. And coming to metal D, it did not react with either iron sulfate, copper sulfate, zinc sulfate or silver nitrate. Now, a small question for you. Using the table above, you have to answer a few questions. Which is the most reactive metal? You saw the reactivity series, and from that you have to deduce this, which is the most reactive metal among A, B, C and D. What would you observe if B is added to a solution of copper 2 sulfate? And arrange the metals A, B, C and D in the order of decreasing reactivity. What would you observe when zinc is added to iron sulfate solution? When zinc is added to a solution of iron 2 sulfate, and write the chemical reaction that takes place for this reaction. Which gas is produced when dilute hydrochloric acid is added to a reactive metal? Okay. I hope you can get the answers for all the questions. You go through the reactivity series. The reactivity series will help you in answering those questions. Now, let us see few chemical properties of the metals. During a chemical reaction, metals transfer electrons. They generally have the property of giving electrons. They transfer electrons from their atoms. When metals react with oxygen, they either produce basic or amphoteric oxides. They displace hydrogen from dilute acids. All metals generally displace hydrogen from dilute acids. Metals react with non-metals to form ionic compounds. And now, let us see few chemical properties of non-metals. Non-metals, they are generally electron acceptors. They accept electrons in a chemical reaction. Non-metals produce acidic oxides when they react with oxygen. Non-metals do not displace hydrogen from dilute acids. They react with metals to form ionic compounds. Now, children, let us have one quiz. It is your quiz time. Your first question: when magnesium and manganese react with dilute nitric acid, the gas liberated is hydrogen, oxygen, carbon dioxide or sulfur dioxide. Now, think and answer which is the gas that is liberated in this reaction. The answer is hydrogen. Your second question: bubbles are released slowly when copper metal reacts with dilute acids. We saw that. This means copper is most reactive, least reactive, highly reactive or non-reactive. Now, think what is the answer? Let us see what is the answer. Yes, the answer is, this means that copper is least reactive because the bubbles are released slowly. And this is your another question. Look at this reaction and identify the correct statement. So, here comes your reaction. Copper sulphate is reacting with iron, which is giving rise to ferrous sulphate, and copper is released. Now, what is the statement? See, copper is more reactive than iron, sulphate is more reactive than copper, sulphate is less reactive than iron. Which is the correct statement? Could you identify? Now, let us see which is the correct statement. Yes, it is iron that is more reactive than copper. Here another question. Aqua regia is a mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of. The question is, you have to identify the ratio in which you find hydrochloric acid and nitric acid in aqua regia, and your options are: is it 3:1, 1:3, 3:4 or 4:3? What do you think it is? Now, let us see which is the correct answer. Yes, it is 3:1, 3 parts concentrated hydrochloric acid and 1 part of concentrated nitric acid is the mixture of aqua regia. Another question for you. The quiz: the oxides produced when metals react with oxygen are amphoteric only, basic only, acidic, either basic or amphoteric. Now, what is the correct answer? The oxides produced when metals react with oxygen are like this in nature, and the right answer is they are basic or amphoteric. Either they can be basic or they can be amphoteric. Another question for you. Non-metals react with metals to form. You have to identify the product. Covalent compounds, acidic compounds, ionic compounds, basic compounds. The correct answer is they form ionic compounds. Non-metals and metals, they react to form ionic compounds. I hope all of you answered it correctly, and congratulations to all those who have answered correctly, and better luck for those who could not. You will be able to answer in the next class. Now, let us have a short recapitulation of whatever we learnt in today's class. Metals and non-metals, few chemical properties of metals and non-metals, the activity series, the reactivity series, the reactions of metals with non-metals. And it's your assignment or your homework time. I'll give you few questions which you have to answer and promptly show them to your teachers. So, now write the chemical equation for the following reactions: reactions of iron with steam, reaction of calcium and potassium with water. Which of the following pairs will give displacement reaction? When sodium chloride solution is reacted with copper metal, when magnesium chloride solution is reacting with aluminum metal, or when silver metal reacts with ferrous sulfate solution, or when copper metal reacts with silver nitrate solution. So, you have to think and answer which among these four will give displacement reaction. Now, generally you have observed that food cans are coated with tin and not with zinc. So, among the four you have to select one reason. Is that because zinc is costlier than tin? Is that because zinc has a higher melting point than tin, or is it that zinc is more reactive than tin, or is it that zinc is less reactive than tin? Now, another question: name two metals which will displace hydrogen from dilute acids and two metals which will not displace hydrogen from the dilute acids. Again, here you have to think about the reactivity series. What type of oxides are formed when non-metals combine with oxygen? You have to give reason why platinum, gold and silver are used to make jewelry. Sodium, potassium and lithium are stored under oil. They cannot be stored just like any other metal. Aluminium is a highly reactive metal, yet it is used to make utensils for cooking. Why? You must have seen tarnished copper vessels being cleaned with lemon or tamarind juice. That you have seen, that you must have seen your parents or your grandparents doing at home. So, now you have to explain why these sour substances are effective in cleaning these vessels. Differentiate between metals and non-metals on the basis of their chemical properties. There is one more question. There is a person called Aman who went door to door posing as a goldsmith. You know who is a goldsmith? Who makes ornaments, gold ornaments. He promised to bring back the glitter of old and dull gold ornaments. So, he was just going to door. There was a unsuspecting lady, so who gave a set of bangles, gold bangles to him, which he dipped in a particular solution. And when he took it out, it sparkled like new. The bangles, they were looking as though they are very new bangles just brought from the store. But then after she observed, the weight of that bangle was reduced drastically. Now, the lady was upset. She had an argument with Aman. She said, "No, you are cheating me." So, now after a futile argument, Aman couldn't do anything. He just took a hasty retreat. He walked away. Now, your question is, you have to play the detective to find out the nature of the solution he had used to sparkle the bangles. So, now you have to think about this lesson and then you have to answer this question. You actually learnt in the lesson what is the reason for this. I hope all of you could learn something in this session and you will answer all the questions that have been asked to you and you will be ready with the answers for the next session. We will all meet in the next session. Till then, namaste.